I did this question algebraically, but I'm just going to share with you how the answers did it, because it is really nice. First up, they took the 206 legs and they minused the 6 legs that the staff have, because we're told that there were 3 members of staff. So 200 legs after minusing staff legs. Then what we can do is consider the average table. Because some tables might have lots of people around, some without not many people, but we can just average it out. And we're told that we've got 3 legs from the table. We've got 4 legs per chair, and there are 4 chairs on each table. So that means it's going to be 16 legs from the chairs, and 3/4 of the chairs are occupied. So there's going to be 3 chairs occupied. 3 people, that means, and each person has 2 legs, so there's going to be 6, which gives us, for an average table, 25 legs. And therefore we can do 200 divided by 25 to work out the number of tables. It's going to be 8 tables. And we're asked how many chairs the cafe has. We know that there's 4 per table, but 8 times 4 gives us an answer of 32. I wish I could say that's how I did it, but I kind of went with a more brute force algebra approach, which I'm going to share. And to be honest, if it came up again, I think I'd do the same. Just feels a bit more natural to me to get algebra involved, but I do appreciate that solution. So I said that, right, first up, if the number of chairs is C, then C is equal to 4t, where t is the number of tables. This comes from the fact that there are 4 chairs at each table. So I'm just writing down an equation to show that. And then because we know that 3/4 of the chairs are occupied, then I'm going to say that I've got U number of people. I can't say C for customers, so I went with U for like the second letter in customers. So U is going to be 3/4 of the number of chairs. And then we can write down an equation. So the total number of legs is going to be 4 times the number of chairs, because there's 4 legs per chair, plus 3 times the number of tables, because there are 3 legs per table, plus 2 times the number of customers, because each customer has 2 legs, and then we've got this extra 6 that comes from the staff, and that's going to equal 206. You can see this is more involved, but it follows quite logically, I think. I can minus the 6 to get 200 again, but now I'm going to substitute in some of our earlier results. I want the number of chairs, so I'm going to replace U by 3/4 C, because then I'm keeping it in terms of the number of chairs. I'm going to rearrange this formula here, though, to make it T is C over 4. So then I maintain the number of chairs here as well. So 4C plus, actually, I just replace T by C over 4 and then write it all down. So 4C plus 3/4 C plus, it's going to be 3 over 2C. Once I've done 2 times 3/4, that is going to equal 200. I went ahead and times true by 4 just to get rid of the fractions. It just felt like it would make things easier. So 16C plus 3C plus 6C is 800. And then I get the same as I did in my previous answer, 25C. Oh, sorry, it's not the same because I'm dealing with the number of chairs rather than tables, but it's a similar kind of equation. And 25 goes to 100 4 times, so it's going to go into 800 4 times 8 times, which again gives us our answer of 32.